Bismillahirrahmanirrahim. Dear students, Assalamu alaikum and welcome to office.com.pk. This is your chemistry class and we have been discussing about the unsaturated hydrocarbons and we were discussing alkenes. So in the previous videos we discussed about an introduction to alkenes, then we discussed about their preparation. So today we are going to start the properties of alkenes. First of all, we will discuss the physical properties of alkenes. The first property is that the first three members that are ethene, propene and butene, they are gases. Then from carbon number 5 to carbon number 15, carbon 5 to carbon 15, they are liquids. And as we move towards higher number of carbon atoms, the higher members will be solids. So the first property is related to the physical state of alkenes. The second point is that they are insoluble in water. And soluble in alcohol. We all know that all the organic compounds, they have this property that they are insoluble in water and soluble in alcohol, because water is polar and organic compounds are non-polar. So a non-polar substance is never soluble in polar substance. The third property is that they have a characteristic smell or odor. And they also burn with a luminous flame. Luminous means shiny or visible flame. Then we have the fourth property, that is they show weak polar properties up to some extent. The reason behind the weak polar nature it will be up to some extent, and the weak polar nature is because of the hybridization. The reason is hybridization. So this is about the physical properties of alkenes. Now let us discuss about the reactivity of a pi bond, because in alkenes there is carbon-carbon double bond, and we all know that in double bond, first bond is sigma bond and the second bond is the pi bond. So now we will discuss the reactivity of there is involvement of pi bond. We all know that. Now when a pi bond is formed, basically the p orbitals in the formation of a pi bond, the p orbitals, they are involved, and what happens is that they overlap in parallel manner. As a result, the probability of finding the electrons, will be away from the line of joining the two atoms or the two nuclei. It will be away from the joining point. Or you can say the joint. The point at which the two nuclei they are joined together is the point of junction or the point of joining. So the electrons will be away from that point of joining because of the formation of pi bond. Due to this reason, the pi electrons, they are, this is a symbol for electrons if you want to write shortly, but do not write it shortly in your exams because it is not acceptable. I am writing it just so that you can understand it easily. The pi electrons, they are less firmly held, means they are not strongly held by the nucleus. So a pi bond, as the electrons are not firmly held by the nucleus, as a result they are free up to some extent. So the pi bond is easier to break, and it is a weak bond as compared to a sigma bond, because in sigma bond the two nuclei, they come closely, they are held closely and tightly, due to which it is very difficult to separate them, and that is why the bond becomes saturated. Whereas here the electrons are not held strongly by the nucleus, and as a result the pi bond is easy to break, and it is a weak bond as compared to the sigma bond. So during a reaction it will be easy to break a pi bond, and it will make the alkenes reactive, because when the pi bond will break, the electrons or the bonds will be available for further bonding, hence the reactivity of alkenes will be enhanced. So in addition to this, the loosely held pi electrons, they are more exposed, the pi electrons are more exposed to electrophiles. Electrophiles are electron loving species. So electrophiles, they find it more attractive to attack the electrons of alkenes, and ultimately alkenes are more prone, or they are more exposed to electrophiles for attack. Hence the alkenes, they are easily involved and they easily participate in electrophilic reactions. So this is all about the properties, the physical properties and the reactivity of alkenes. In the next video I will discuss about some reactions of alkenes. Till then, take care of yourself, keep studying and keep watching office.com.pk. Allah Hafiz.